Hello and welcome back to another VMK in the game development series. In this VMK we're going to start working on a console window. You'll notice that in a lot of first-person shooters you have the ability to press tab or the tilde sign on the keyboard and a little window comes down usually from the top of the screen, and in this console window you can type in commands, maybe set a couple settings to customize how the game is run. Well, we're going to reproduce this console concept by adding in a window that scrolls down from the top of the screen when you press the tab key, and we'll use this console window to display statistics like the number of frames per second, maybe other statistics like where is your current position inside of the game world, things like that. And later on, if you want to add in other things into this console window, you can do that as well. But before we can get started with the console window, there is a few things we need to clean up. In my development of this game engine, I'm sort of developing it on the fly. As I develop new things to add to the game engine, some things that I've done previously may start interfering with the way that I do things now. And with this console window, this is one of these cases. So to fix this, what we need to do is go and modify the way that our GameOGL class works per frame. You'll see down here, we have a variable here that keeps track of the state of the game. When we are playing the game, then we go and calculate the delta time, we check to see if it's within the range here, and then we update the current game time according to how much of the delta time has been updated. Then we call update game, which if we go into here, we see that we handle the keyboard, handle the mouse, and then we have player update where we pass in the game time, and we also have an update function call where we pass in the delta time. This delta time we're going to need in a few places, and I don't want to be having to pass it into every single different function that we're going to be needing to have this variable. So instead, what I decided to do is go inside of the scene class and create a variable. This variable is going to be responsible for keeping track of the delta time that passes with each frame. So the variable here, I call it m_f time change. This is the time that has elapsed since the last time that we rendered. We're going to set this guy inside of the constructor equal to 0 initially. Let's go and do that. And now we need to be able to update this variable any time that the time changes. And the time changes due to the OpenGL class here. So instead of, where were we here? Inside frame here, we calculate the delta time. And what we're going to do is update the current game time here. We're also going to update that variable within the scene here. We already have a pointer to the scene inside of our game engine. It's called m_p scene. So we can just do this. And the delta time is going to get passed into that variable. Now inside update game, we no longer need to pass in the delta time inside of the update function because we already have that variable internally set for us. So let's modify this and go inside of the scene.h, and underneath update, here it is here, we'll remove this variable, and inside of here we need to find our update. Here it is. So now instead of this variable being used here, anytime we want to use the delta time inside of our update function, we're going to use our member variable instead. So we'll call m_f, what did I call it? Time change. Like so. Okay, let's go and compile this, make sure I didn't make any mistakes. And if we build it and run, everything should still run the same as it did before. Looks like I missed something here. Oh, this here is a double, but our variable is a floating point number, so we do want to cast it to a float. And looks like I missed something here. Oh, I erased the bracket. Okay. The other thing I changed since the previous video is I just added a new model of a card just so that there's something on the screen that we can play around with. Now inside of scene, anytime we want to refer to the time change, we can just use this variable, and we can use it in any function we like. And this is going to be handy because our console that we're going to be creating, we're going to have to animate. And the animation is going to be time dependent, so that's why we need this variable here. There is one other thing I would like to change, and if you do a search for the function glBlendFunc, you'll see we have two instances of it. There's one instance here inside of GameOGL.cpp. This is in the initialize function where we define how OpenGL will be doing the rendering. We set up the normals, the background colors, things like that. And we specified that our blending function is going to use source alpha and 1 minus source alpha. You'll notice that there is another instance of glBlendFunc here inside of the HUD. Because we enabled the blending function, we then go and print anything to the screen. Right now we've commented everything out, so we don't do that. And then we go and disable blend function. Well, we're not going to be changing the blending function anywhere, so it's okay to delete this one glBlendFunc because it's really not necessary. If later in the future we do need to change the blending function, then we'll have to come back and make modifications here. But for now, we're only going to be using this one type of blending function, so it's okay just to set it once and then we can leave it how it is. Alright, now that we've made those changes, we can start implementing the console window. Let's go into PaintShop Pro to see an overview of how this console window is going to work. Okay, imagine that this is our window that we're going to be rendering everything inside, and here's our title bar where we have the name of our game, and then we have our little X and minimize button located at the top right hand corner. What we're going to be creating is a console window that's going to appear at the top of the screen. So whenever we activate the console button, which we're going to be using the tab key, but you can program it to whatever you like, as soon as you hit the tab key, what's going to appear is a console window like so. But it's not going to appear right on the screen initially. What we're going to do is we're going to animate it so that as it's coming up, it's basically going to start off the screen and it's going to scroll down slowly like so until it's fully visible right above, right below the title bar of our window. We're going to make it sort of transparent so you can still see through it, whatever's back here in the 3D scene. But we're also going to have a white bar along the bottom here, which later on we're going to be able to use as an input. So if you type something in, then the text will appear here, and we can execute scripting commands to cause other things to happen inside of the game engine. So this is what we're going to be achieving. We're going to need to specify a couple parameters. The first being we need to specify how high this console window is going to be. We also need to know how wide this console window is going to be. So these are going to be two parameters we're going to use. The way we're going to render this console window initially is we're just going to use a regular rectangle to fill in the yellow part here that's going to be of this height and of this width. And then we're also going to specify to render this white rectangle down here, and it's going to be offset from the white one slightly so that I don't remember exactly, but there's going to be a few pixels this way and a few pixels vertically from this bottom left-hand corner. This bottom left-hand corner of the yellow console window is going to be our home position. So this is what we're going to be using to control everything. Let me clean this up a little bit here so you can see. This coordinate right here is the most important coordinate out of this whole console window here. This is the home location. So we're going to be using this point to determine how wide to make this rectangle, how high to make it with respect to this point. Now the other thing we need to know when creating this console window is how big is our window itself. So how wide is it, as well as how high is it? You'll remember that inside of our code, at the very beginning, we specify a size for our window. But if you're running in full screen or in windowed mode, the actual size that you have down here to render in is going to vary. The variation comes in play because if you use a windowed application, you need to use up some of the pixels for the borders here, as well as for the title bar up here. So if you specify to have an application run at 800 by 600, the client area, which is this area down here, so basically from this corner all the way to this corner, not including the borders or the title bar, is the actual area that we can use to render in. And that area would be less than 800 by 600. And you're going to see this in a minute when we go into the code. So what we need to do is we're going to need to determine exactly how big is our client area that we're going to be working with. And the client area is going to have an initial position, 0, 0 is going to be here, 0, 0. So this is an important thing to remember, because in our HUD, when we go and render things to the screen, 0, 0 for us is located down here. Now this won't matter too much initially, because this coordinate system and this coordinate system that we're using won't interfere with one another until we start having to do things with the mouse. For instance, get mouse input for GUI controls and things like that. Once we start implementing a GUI, then we're going to have to take into this consideration that our coordinate system has a different origin. But for now, we're going to be rendering with 0, 0 located down here. So when we go and render this yellow rectangle here, we need to know exactly where this coordinate is located inside of our client area. Well, we can see it's going to be located at 0 in the x direction, but the y value is going to be equal to the height of our client area minus the height of our console height here. So using that, we're going to be able to figure out where to place this point here. And then as we're animating, we're going to be basically moving this point upward until it's off the screen, basically up here underneath the title bar, so that when we render it, we don't see it. So that's the way that the console window is going to look and behave. Now let's go into our code and start implementing the functions required to get this thing rendered onto the screen. To start off, we're going to need to know the exact size of our window. And the way that we have our code structured right now is we specify the height and the width of the window that we want to create inside of this parameter here, window param, which we pass into our game engine whenever we call create. So inside here, you see we take the window parameters for the height and the width, and down in here we use these parameters to specify the size of the window that we want to be creating, right in here. But after we created it, we need to have a mechanism to save the actual value of our client window. Right now, we don't have a mechanism for that. So we're going to create a new variable, and as a matter of fact, there's going to be a new class to hold these variables. All of the sizes for the window itself are currently inside of the GameOGL class. When we go and render the console window, all the rendering is going to happen inside of the scene class. It's actually going to happen inside here, inside of the HUD. So we need to have a mechanism to be able to transfer data from GameOGL into scene.cpp easily. And there's going to be quite a few parameters we're going to be needing to be updated every frame a little bit later on. So what I've decided to do is to create a new class that's going to be used by both this GameOGL class and the scene class. They're going to share this class by referencing to one pointer. By doing it this way, we can have both of these classes accessing the same variables through one pointer. So if GameOGL updates something, scene.cpp will be able to see the changes immediately. The class that we're going to create, I'm going to call UserSettings. And so let's go and create that right now. We're going to place the UserSettings class inside of the game engine project up here. And if we just expand this, oh, there's one other thing I would like to change as well. Initially, when I started making this project, I started grouping things into individual folders like so. We had a main, a core, and a game OpenGL. I've decided to get rid of this main folder here because it's really not serving much of a purpose. I'm going to take all of these things here from main and put it inside core. So what I'm going to do is I'm going to select the main folder here and delete it, which will remove a couple files here from our project. After they've been removed, we'll go into the folder structure inside of Windows Explorer here and go into the main directory, highlight those files which we just took out of our project, and place them inside core. We'll go back up, delete the main directory, and with that one deleted, we can now go back into our project and reinsert those files that we removed. So add existing items. Underneath core, we want to add the main, stdafx.h, and stdafx.cpp. After you put them in your project here, you need to drag them into the appropriate directories just to keep them organized, like so. After making that change, I think if you try to compile your project, you may get some problems. Oh no, you won't get any problems because we didn't actually create a new directory. But what you could also do is go underneath the project settings here, and underneath C++, you'll see that we've added the main directory here. You can actually go in and remove this because we no longer have that directory. You can do the same thing for these other projects, but I'm not going to bother. It's not going to hurt us by having that in there. Okay, now that we've cleaned that up a bit, let's go in and make our two files for the UserSettings class. So click Add, New Item, CPP, and we also want to add a .h. And again, we want to drag these into the core folder just so that everything is nice and tidy. Let's just go take a look to see where those files were created. And oh, right, Visual Studio ended up putting them right into the root directory here, which is not where we want them. So let's go delete them out here. And inside here, drag and drop these new files we just created into the core folder. And then once it's in there, we can go in and add the files that we just created. UserSettings.h and .cpp. And then drag them into the core. Okay, so now we've just added those two new files under the core directory inside of the game engine project. Let's open up the UserSettings.h and take a look. Okay, inside the UserSettings.h, we have our standard stuff at the top. We include core.h, and then we have our class definition. We have a constructor and a destructor, and then down here inside of the member variables, we have the width and the height for our resolution and the width and the height of our window. So this here is going to represent the desired window size. So here we're going to specify, like, we want to have 800 by 600 window. Down here, we're going to be setting these variables up so that these match up to the width and height of the client area. And again, the difference between these two numbers is the 800 by 600 values would basically represent this, 800 by 600, where the value goes right up to the very top of the window, and the width goes right up to the very edges of the window. The client area is this area right in here. So this would be less than 800 and less than 600 because we have some pixels used up for the title bar, some pixels used up by the borders here, and other controls on the window. If you're using a full screen application, then the client area should be equal to the full screen resolution size. But if you're not rendering in a full screen, then your client area will be less than your full screen resolution. So that is why we need two different variables, one for the resolution and one for the client size. So I'll write in here, client window size. Okay. Now inside of the user.cpp, we're only going to be setting the width and the height of our screen resolution. So if we go into our, I think it was in our main. Yeah, in our main here, we're currently setting everything to be 800 by 600. We're going to change this code in a second. But instead of doing this here, what we're going to do now is set everything up inside of the constructor of this UserSettings class instead. Now, because I've defined everything as being private, we're going to need to write up some accessor functions to be able to access these variables here externally. Instead of writing these accessor functions inside of the CPP, I'm going to write them inside of .h because I want to make them inline. And I'm only doing this so that I can get a little bit of a speed boost a little bit later on. So the first thing we're going to need are two functions, getResolutionWidth and getResolutionHeight, which are just going to return our resolution member variables here. And we're going to be using them inside of the main.cpp here to set the width and the height values for this window parameters variable. But before we can do that, we obviously have to create an instance of our UserSettings variable. So we'll just do that right, well actually let's do it below the air handler but above the Windows parameters. So we're going to create a variable called UserSettings, and it's of type UserSettings. Now notice that C++ is case sensitive, so you're allowed to do this. I've named both of these exactly the same thing, but the only difference is that I have a lowercase here and an uppercase here. Our class is defined using the uppercase. The variable that we're going to be using that uses this class is lowercase. So as soon as we create this variable here, we're going to go inside of the constructor and set up the resolution to be 800 by 600. Now that that's been set up, in here we can use that variable, UserSettings, to get the resolution width, and we can do the same thing with the height. Okay, so now we've got the width and the height passed into this Windows parameter value. But I want to pass in the user settings into our GameOpenGL class so that I can use it for other things later on. And the way I'm going to do that is I'm going to pass it in as a pointer inside of the constructor here. So by doing this, I say I want the address of this variable. So in other words, I'm going to get a pointer to this variable, and I'm going to pass it into the constructor. So I need to now go into the GameOpenGL constructor. We can find that right in here. And we'll specify we're using a user settings, and we're going to pass in a pointer to user settings. We'll need to also modify the constructor here. And now what we want to do is also add a member variable inside of the GameOpenGL class so that we can save this pointer. So I'll just put it right at the very bottom. Like so. And inside of the constructor, we're going to define what this guy points to. Okay, so now our GameOpenGL class has access to this class here. Now, if we were to compile this, we're going to get some errors because our GameOpenGL has no idea what this user settings class is, because we haven't included the header file anywhere. So let's go into GameOpenGL.h, and at the top here, we'll include UserSettings.h. Now if we compile this, it should be okay. And let's also try to compile main.cpp. It's fine as well because it's including GameOpenGL.h, and GameOpenGL.h includes UserSettings.h, so that's why we're able to use this variable down here. Alright, that's a good start. Now we need to specify the actual size of our window after it's created. The creation process happens inside of the create function, located down here. Right here. So if we're creating a full screen window, then we're going to go into here. Otherwise, we're using a window or non-full screen, and we're going to be in here. So depending on which of these branches we're going to be taking, we need to appropriately set the variables inside of this class now. These ones right here, window width and window height. And again, because these guys are private, we need to have a function to be able to set these. So we're going to go right in here and specify the following function, set window size. So this will save the width and the height of the window, this is the size of the client area, within these two variables, iWindow width and iWindow height. So back inside GameOpenGL.cpp, we need to be able to figure out what is the client area. If we're running in full screen mode, then the client area is equal to the size of our screen resolution. So we can set the window size equal to the width and the height that we specified up above. And that was located right at the top here, right here. Width and the height is specified to be the parameters width and the height, and you remember that these values were set to the resolution width and the resolution height. So that's what we set the screen size to be whenever we're working in full screen. However, when we're not full screen, then we need to figure out what is the client area size. Luckily for us in Windows, there's a function to get the client size of a window, and it's called getClientRect. This guy here requires a pointer to a rectangle structure, which is this thing here, and a handle to the window we want to get information about. When this function executes, it's going to fill in the 4 values inside this rectangle structure, which we can then use when we go and call set window size. So the right value and the bottom value is actually the width and the height of the window that we are going to be working with. Okay, after doing all that, we now have the current size of our client area saved for us to use. But for us to be able to use it, we need to have a pointer to this user settings within our scene class. So let's go into scene.h, and down here in the member variables, let's add a new variable. Like so. And inside of the constructor, we need to now initialize that new member variable. So m_p user settings is going to equal, and we're going to be using this guy to get the variable, m_p user setting. Notice that this variable right now is private, so we can't actually do this. Our compiler would give us a warning, or actually an error. What we need to do is go back inside here and just move this variable out of the private section and into the public section, like so. Alright, so now we have access to the user settings from within our scene class. Now we're pretty much ready to go. Let's just build this, make sure there's no errors. Oh, there is something wrong here. It says here, no operator found, which takes right-hand operator, user setter, and pointer. Okay, this is a pointer, and oh, I see what I did. Back here, I forgot to define our variable to be a pointer to user settings, like so. That should fix the problem. Let's go and compile this and build it, make sure everything's okay. Okay, we've set up the framework. Now we can actually start using it to create our console window. First thing we're going to do is create a function that, when called, will render our console window to the screen. So inside of scene.h, we're going to make a new function, and I'll put it right here underneath the HUD. I'm grouping these sort of together because the HUD will usually call this console render function. And we'll go into our scene class, wherever our HUD is, and I'll just put it right below here. Actually, before I show you the console render function, we should define a few variables so that we can define how wide the console is, how tall it is, and other parameters like that. So let's do that first. Going back into scene.h, we'll need to create a new variable. I'll put it here underneath user settings. So here we go. I create a new variable called m_ConsoleParam, and it's of type ConsoleParam. This is a structure that I just created, so if we go up to here where the structures are, you can see what it contains. It has a color OpenGL variable, so background color, so this is going to be the color of the actual console window. We have some parameters here to indicate the size of it, so the width and the height, and we also have this parameter here which indicates the position of the console window vertically. Here, remember back inside PaintShop Pro, this here is the home position. So what we're going to be interested in is where is this position vertically along the height of this window. We're not going to be scrolling the console window horizontally, so we can say that the x coordinate will be 0, but the y will change as we're animating. The structure itself, I created a constructor. You don't have to do this, but I did it anyway, just because I don't like having variables that are uninitialized. So by default, I'm going to set the background color equal to be sort of this yellow color here, and I do specify an alpha value, so it's going to be slightly transparent. The width and the height by default are going to be set to 400 and 100, and the position initially is going to be 0. A little bit later on, I'm going to animate this, so we're going to be updating this position value. So let's save that, and going back into the scene.cpp, if we want to see the console window on the screen, all we need to do is call render console, I think it was called. Is that function that we created, console render. We should now go in and actually write the code for this guy as well. So going into here, we can see now our console render function call. First thing we do is we set the model view matrix to be an identity. We use GL begin GL quads because we're going to be rendering a rectangle on the screen, and we're going to render the background color first, so this is going to be the yellow color. We specify GL color 4F to be the red, the green, and the blue values, and also the alpha value here. And then we have our 4 vertices for our quad. The bottom left-hand corner is going to be 0 and the current position of the console. Next coordinate to the right of that, actually let me go into here. So we're going to render this guy first, then we're going to render this guy second, then this guy, and finally this guy over here. So this is going to be 1, 2, 3, and 4. So the second guy, we're going to go across the entire width of the console, and then the position vertically is going to be the same as it was before. Then the next guy up is going to be the same value horizontally, but now we got to go up the height of the console window. And then finally we come back to 0 for the x, and the height remains the same as it was previously. After rendering the background, we need to render that white strip along the bottom, which we're going to use for text input a little bit later. So we specify to use GL colors 3F 111, and we're going to specify x coordinate here of 2. So I'm moving over 2 pixels from the edge, and the y value is going to be whatever it is here plus 2 pixels. So I'm giving a 2 pixel buffer. The next guy over, so this is this guy over here. We're now rendering this coordinate, this coordinate, this coordinate, and this coordinate here. So we did this one first, the second one is here. We're going to go across to the full width, but then we're going to backtrack 2. We're going to remain at the same height. Then we're going to go all the way up to the third coordinate, so this stays the same, but now this value here changes. We're going to give a vertical height of 16 pixels. So that's why we have 16 plus the 2 that I've allocated here. and then we're going back to coordinate number 4, which has x coordinate of 2, and the y coordinate is the same as before. Okay, now if we're to render this, or actually run this, let's take a look to see what happens. Alright, so we can see our console being rendered on the screen, and it's transparent because I can see through it, and we have that little white border along the bottom. And as we move, you notice that the console stays fixed on the screen, which is handy. That's great. But we have a few problems here. The console itself is not the entire size of the screen that we're using. The other thing is it's not located at the top left-hand corner, it's located at the bottom. Both of these problems are easily fixed, but let's approach these one at a time. The console width right now is coming from the constructor here. We specified to have size of 400 and a height of 100. Well, we want to specify these to match the width of our window. And the width of our window is defined inside of our scene constructor right after we get our pointer to our GameOGL. Because GameOGL gives us this pointer, and then once we have this pointer, we can get the size of the window. So down here, let's set up some values. We have our parameter mConsoleParam, and we want to set the width, and the width is going to come from our MP UserSettings. And we want to get the parameter for iWindowWidth. Well, we don't have an accessor function for this yet, so we need to go and implement this. So let's put this on hold and go into UserSettings.h. So we create a function here called getWindowWidth, and I also created another one, getWindowHeight, which just returns the member variables inside of our class. Now we can go back into here and call getWindowWidth. Now this guy here will return to us an integer, so we want to convert this to a floating point number because that's what this parameter here uses. So just cast it as a float, and let's try this out now. Okay, so our console window now completely fills the entire width of our screen. That's great. All we need to do now is move it to the top of the screen rather than the bottom. The location of the window is coming from one variable, this one here, mConsoleParam FY position. So what we need to do is update the location of this guy so that he's located at the top rather than the bottom. Because right now, by default, he's been set to be 0, and 0 is the bottom left-hand corner. So if we go back inside of the constructor for our scene, we can quickly make a modification here. Instead of setting the width, we want to set the y value, and we'll set the y value equal to getWindowHeight, but we want to offset it by the height of the console window itself. So we'll subtract mConsole height like so. Now we should be able to see our console window in the top left-hand corner rather than the bottom left. And there we go. So all that's working perfectly. Now there's one thing we'd like to add, and that is the animation of this guy to be turned on and off. We're going to handle this with a keyboard press of the tab key. So let's go in and first write the code to grab the tab key, and then second we're going to create the code to actually animate the thing. So to grab keyboard presses, we're going to have to go back into Game Engine, underneath the GameOGL class, and inside Handle Keyboard. Or sorry, not Handle Keyboard, but Message Handler. Anytime that a key is pressed, we go into here, and anytime a key is released, we go into here. Well, when a key is pressed, we'll want to do a check. If the key that was pressed is the tab key, so this is the key code for the tab, then we want to do something here. Otherwise, we'll go and do the regular stuff, which is set up this variable to set this value to be true. Now the thing we want to do here is we want to toggle the state of the console window. So to do that, we'll need to create a function to toggle the console. And the function itself should be put inside of the scene because that's where we're rendering the console anyway. So back inside scene.h, we're going to have to create a new function, and I'll put it here underneath console render, and I've named it console toggle. So back in here now, anytime we press the tab key, we want to call mp scene console toggle. Now let's go and implement this console toggle function inside of scene.cpp. Let's put it underneath the console render. What I'm doing here is I'm taking a parameter called bMoveDown, and I'm toggling it from whatever it was to the opposite of whatever it was. It's a Boolean. We haven't defined this yet. We're going to do this next. So all we're doing is we're just taking whatever value it is, negating it, and saving it back and onto itself. So we're toggling it from true to false and false to true. Now let's go back into scene.h and create that variable. This is going to be a flag that indicates the direction of motion, but initially the direction of motion is not going to be down, it's going to be up. You'll see how this works as soon as we start programming the animation. So initially we're going to set this to false. Okay, now that we have this new variable, we should use it inside of our render function to determine whether we render our console on the screen or not. Let's see, where is it? Inside of our scene, we're looking for console render. So we're going to be checking to see whether our parameter is set to be true. If it's true, that means we want to see it. Want to see console. So we're going to render it here. Otherwise, we don't want to see it. So we're not going to be rendering it on the screen. Now to render it on the screen, we already know the maximum downward position, and that was already set for us inside of our constructor. So let's go in here and actually just cut and paste some code. We'll take this, and going back to the console render, we want to see it, we want to set up the Y value equal to all of that. If we don't want to see it on the screen, then all we do is we remove this part here, because then our console window is going to be off the screen and you won't actually see it. So now let's go and render this and see how well it works. So initially it's off the screen, and when I hit the tab key, you notice it appears. And when I hit it again, it toggles and disappears. So we've achieved the ability to toggle the console on the screen. But we don't want to just have the console appear the way it is now. It'd be nice to have a nice smooth animation of it coming down from the top of the screen. And then when we hit the tab again, we want it to scroll back upward. So let's go and implement that. First thing we need to do is create a couple more variables to use inside of our console parameter here. So we're going to add in a thing called speed, and two values here, minimum and maximum. So the speed is going to indicate how quickly the console is going to scroll on and off the screen. The position is the current location of the console, and then the min and the max are going to indicate the minimum and maximum locations for the Y coordinate as we're scrolling. The minimum is going to indicate when it's fully open, and the maximum is going to indicate where the console is when it's off the screen. We should initialize these values to something. So in here we're just going to set up the speed to be 150 pixels per second. Let me write this in here. The position is initially 0, and the minimum value we're going to set to 0 and the maximum set to 100. These values are actually going to get overwritten inside of our scene constructor here, because the minimum and maximum really depend on the size of our window. So same as what I just did inside of the console renderer. Let me just refresh your memory here. Console renderer. You'll notice that when it's moving down, then we want to see it on the screen, so we take the height minus the actual height of the console window. When it's off the screen and we don't want to see it, we just specify it to be the height of the window. If I go back up here now, you'll see that the maximum, when it's off the screen, it's set to the height of the window, and the minimum, when it's fully on the screen, we set to be the height minus the height of the console. So those values have now been initialized, and let's go in and actually use these to animate our console whenever we press the toggle button. So inside of console render, we're going to have to change this code here so that it animates. So now we check to see if it's moving down and whether the Y position of the console window is greater than the minimum. If that's the case, then that means that the window is still scrolling downward. So we need to update the console position. So we take the Y value and we're subtracting its current value by the change in time times the speed. So speed times time is distance, and the distance that the console moves is going to get subtracted from the current location vertically. We then have to check to see if we've reached a limit. So if our console window scrolls down beyond our minimum value, so if it's less than or equal to the minimum, we automatically set the position equal to the minimum. So our console window won't go beyond the minimum value. We have to do something similar when it's scrolling upward. So if it's not moving downward, it's obviously moving upward, and if the position is less than the maximum. If that's the case, we're still scrolling upward, and then we need to update the Y position. This time we're adding rather than subtracting. We again do a calculation to see how much it's moved based on the time. And remember, this is the time variable that I created at the very beginning of this tutorial to keep track of the delta time that was updated from our GameOGL class. Let's go back here. Oh, and last thing here is make sure we stop at the limits again. If the Y value is greater than the maximum, then we just set it equal to the maximum. So now when we go in and run this, we should be able to see our console window scroll on and off the screen. So if I press the tab, it scrolls down. If I press the tab again, it scrolls up. And if I press midway, you'll notice that it actually changes directions, because that's the way that the code is written. So there we go. We have a fully functional console window that we can use inside of our game engine now. In the next video, we're going to be modifying this console window slightly so that we can add some variables to be shown on the screen. Things like frames per second, maybe your current position inside of the game, anything you like, really. But I'm just going to show you those two. Later on, if you want to go in and modify this yourself, feel free, put in whatever you want in this console window. Oh, one thing you'll notice is that when you run your program, the console is initially open, and that's why it's scrolling upward to disappear off the screen. To fix this, you just really have to go into our constructor here and specify that the Y position is not at the minimum, but rather at the maximum. So we can do the following. Now whenever you run your program, the console window will initially be off the screen and you won't see it. And then when you press a tab, it will appear. You can press it again to make it disappear.